love with rocks and minerals. I mean, the colors, the shapes.
And they're the building blocks of modern civilization.
The rocks we pick up tell a story that life couldn't have occurred without rocks. We wouldn't have televisions, we wouldn't have automobiles, we wouldn't have buildings without the mineral riches that we have.
Look at a rock and you think, well, nothing. But this holds the signature of life.
Greetings, I am Thor Florentino, and today you will know more about Earth and life science. After this lesson, you are expected to know more and be more aware of rocks and minerals. Rocks and minerals are all around us. They are everywhere. And what I mean by everywhere is because they can be seen virtually anywhere you look. In your house, there are rocks. It may be because your house is made up of rocks. Our use of rocks and minerals include building materials, cosmetics, cars, roads, and maybe even appliances. But what exactly are minerals? In geology and mineralogy, a mineral or mineral species is, broadly speaking, a solid chemical compound with a fairly well-defined chemical composition and a specific crystal structure that occurs naturally in pure form. So the geological definition of a mineral normally excludes compounds that occur only in living beings. Now, to meet the definition of a mineral, for this substance to be called a mineral, they must meet certain qualifications, certain specifications, and certain requirements. So for example, that substance must be naturally occurring. That substance must be inorganic. It must be solid. It must have a definite chemical composition and an ordered internal structure. So when we say naturally occurring, the substance must not be man-made. For it to be called a mineral, it must not be made by people. Now, when we say inorganic, the substance must not be made by an organism. It must not be made by a person or an animal, and it must not be comprised or composed of other materials. For example, wood and prose are made by organisms and thus are not minerals. There are 7 types of minerals. First is the silicates, second is the oxides, sulfates, sulfites, carbonates, native elements, and halides. So let's focus on silicates. Silicate minerals are rock-forming minerals made up of silicate groups. So this particular mineral is made up of silicon. They are the largest and most important class of minerals. They are the most essential because they make up approximately 90% of the Earth's crust. So when you see a mineral, most probably there is a 90% possibility that that mineral is a silicate. There are a wide variety of examples for silicate. Quartz, feldspar, mica, amphiboly, olivine, and a great variety of clay minerals. Okay, so let's now move on to oxides. Examples of oxides are hematite and magnetite, chromite, manganite, cassiterite, ilmenite, and rutile, franklinite, and zincite. But within these oxides, there is an element. So when we say hematite and magnetite, they are comprised or composed of iron. When we say chromite, chromium, manganite, manganese, cassiterite, tin, ilmenite and rutile, titanium, and franklinite and zincite, hence the name zinc. Okay, so let's proceed to sulfates. Sulfate minerals are a class of minerals that include the sulfate ion within their structure. So within their chemical structure or within their internal structure, the sulfate minerals have sulfate ions. Examples of these are anhydrite, gypsum, thenardite, epsomite, glauberite, kainite, kieserite, mirabilite, and polyhalite. Now, let's proceed to sulfites. Sulfide minerals are a class of minerals containing sulfite or persulfide as the major anion. So examples of these are galena, cinnabar, and chalcopyrite. So the sulfide minerals have sulfide or persulfide as their major anion. So that is the primary anion that is within their internal structure. Let's proceed to carbonates. Carbonate minerals are those minerals containing the carbonate ion. So within their internal structure, they must have carbonate ions. So examples of these are other relatively common carbonate minerals which serve as metal ores. For example, siderite for iron, rhodochrosite for manganese, strontianite for strontium, smithsonite for zinc, witherite for barium, and cerussite for lead. And for the second to the last, or for the sixth type of mineral, we have the native elements. Native element minerals are those minerals that occur in nature in uncombined form with a distinct mineral structure. The elemental class includes metals and intermetallic elements, naturally occurring alloys, semi-metals, and non-metals. So these native elements are commonly divided into three groups, most of which you are already familiar with: metals, semi-metals, and non-metals. So for the metals, examples of these are platinum, iridium, osmium, iron, zinc, tin, gold, silver, copper, mercury, lead, and chromium. But for the semi-metals, we have bismuth, we have antimony, we have arsenic, we have tellurium, and we have selenium. For the non-metals, they are either composed of two elements, sulfur or carbon. And for the seventh and the last type of mineral, we have halides. Halide minerals are those minerals with a dominant halide anion. Complex halide minerals may also have polyatomic anions. Examples of these are atasamite, which has copper, chloride, and hydroxide. The other example is avogadrite, which composes of potassium, cesium, boron, and fluoride. So let's recall. For the 7 types of minerals, we have silicates, we have oxides, we have sulfates, we have sulfides, we have carbonates, we have native elements, and we have halides. Okay, so let's proceed. Let's proceed to rocks. A rock is any naturally occurring solid mass matter. So a mineral can be a rock, but not all rocks are minerals. A rock is any naturally occurring solid mass matter. It is categorized by the minerals included, its chemical composition, and the way the rock is formed. Rocks are usually grouped into 3 main groups. We have the igneous rocks, we have the metamorphic rocks, and we have the sedimentary rocks. So when we say igneous rocks, they are the rocks formed when magma cools in the Earth's crust, or lava cools on the ground surface or the seabed. So after or within a volcano, if the magma cools in the Earth's crust, they can make, most probably they will be able to make igneous rocks. Or maybe even after a volcanic eruption and the lava cools down, most probably it will turn into an igneous rock. So examples of these are andesite, basalt, dacite, obsidian, pumice, rhyolite, scoria, and tuff. So there are two types of igneous rocks. Two types. The first one is the intrusive igneous rock. The second one is the extrusive igneous rock. So in the intrusive igneous rocks, these rocks crystallize below the Earth's surface, resulting in large crystals as the cooling takes place slowly. So it has been established that igneous rocks are formed when magma cools in the Earth's crust. But in the intrusive igneous rocks, the cooling procedure or the cooling process happens slowly. But when we talk about extrusive igneous rocks, these rocks erupt onto the surface, resulting in small crystals as the cooling takes place quickly. So we all know that igneous rocks are formed when magma cools in the Earth's crust. But then, when you are talking about intrusive, the cooling takes place slowly. When we talk about extrusive, the cooling takes place fastly and quickly. Gets? Okay, so let's proceed to the characteristics of igneous rocks. Number one is the igneous form of rocks does not include any fossil deposits. You are now aware of fossils, am I right? Okay, so if there are any chances of fossil deep inside the Earth crust, it erupts out of the Earth's surface and gets destroyed due to the sheer heat these rocks produce. Second, most of the igneous forms include more than one mineral deposit. 3, they can be either glassy or coarse. Fourth is that these usually do not react with acids. Fifth is that the mineral deposits are available in the form of patches with different sizes. So, we're now done with the igneous rocks. Let's now move on to the second type of rock, which is the metamorphic rocks. Metamorphic rocks are formed when existing rocks are subjected to such large pressures and temperatures that they are transformed. Something that occurs, for example, when continental plates collide. So, examples of these are the common metamorphic rocks, which include phyllite, schist, gneiss, quartzite, and marble. It's brief. So let's now move on to the sedimentary rocks, which is the last and the third type of rock. Sedimentary rocks are formed by a diagenesis or lithification of sediments, which in turn are formed by the weathering, transport, and deposition of existing rocks. Sedimentary rocks are largely found on the Earth's surface. They cover 75% of the Earth, which the examples are common sedimentary rocks, which include sandstone, limestone, and shale. So earlier, when we were talking about silicates or the minerals, silicates composes 90% of the Earth's crust. But when we are talking about rocks, sedimentary rocks cover 75% of the Earth. So you must know the difference between rocks and minerals. A mineral is a naturally occurring inorganic element or compound having an orderly internal structure. So minerals must not be made by man. It must not be made by other substances put together. But a rock is an aggregate of one or more minerals. So what we mean by aggregate is that rock is a compound. It is a combined substance which was formerly comprises of a mineral. Let's say, for example, silicates and carbonates, and then For some odd reason, a massive amount of heat melted the rocks, and a cooling takes place. The silicate and the let's say the carbonate combines, which makes them a rock. Okay, so a rock is an aggregate of one or more minerals, or a body of undifferentiated mineral matter. Common rocks include granite, basalt, limestone, and sandstone. You must know this. The study of minerals is called mineralogy, just like the study of systematic group of people is called social sciences. The study of minerals is known as mineralogy. People who study minerals are called mineralogists. Minerals can be described and classified according to their physical properties, which I also need to discuss. The crystal structure and shape called their habit, hardness, measured using the Mohs scale of mineral hardness, luster, the way light reflects on them, color, translucency, how see-through they are, cleavage, how they break, and density, mass to volume ratio. So that's it. That's all you need to know about rocks and minerals. Once again, I'm Thor.